Hi, everyone. I'm Professor Blake Winter from the mathematics program at Medaille College, which is part of SMAT, our Science, Mathematics, and Technology department. And I just want to tell you a few things about Medaille and about myself and about the programs here. So I've been working at Medaille since fall of 2019, and I've been teaching various courses for people in all sorts of different programs here. Just about everybody ends up having to take mathematics courses, but I've also been working with our applied mathematics majors. My own area of specialization is actually in a branch of mathematics called topology, which studies a lot of different things, and it has many applications from physics to biology to just really a lot of different types of stuff end up involving things that come out of this branch that we call topology. So my own area of particular focus is on something called knot theory. And knot theory studies things like, let's say that you have some sort of a loop, and I'm just using a pair of earbuds here to demonstrate this. Well, normally, you would like your earbuds to be straightened out like this, right? But sometimes you probably find that when you pull them out of your pocket or whatever, they have some kind of weird knotting in them like this. So they're looped around. But maybe when they come out looking something more like this. And if they're like this, they look messier, but actually they're simpler because they just pop straight again. So the branch of mathematics known as knot theory studies questions like, when can things just be popped straight like that? And when are they wrapped up in such a way that actually I can't just pop it straight? I have to, grab the end and bring it back through the middle and do something like that in order to get things straightened out again. One of the areas where this is useful is in studying problems involving DNA. So, for example, strands of DNA, they can get wrapped up with each other in different ways, and we want to know, what are the different ways they can get wrapped up? How could they end up wrapped up that way? How could they get unwrapped? But knot theory also has applications in physics. It's a very interesting subject just from a pure mathematics perspective, which is the area that I tend to focus on. So that's my particular area of focus. Now, here at Medaille, we have two different sort of tracks for the applied mathematics majors. One of them is focused on data sciences, so analyzing data and things like that, and the other is for actuarial sciences, which really study the kinds of questions, I like to think of it as the sorts of questions that are of interest to people working in risk analysis, places like insurance and that sort of thing. So with either of these kinds of focuses, you will be well prepared for a job that involves analyzing data for policymakers, working at think tanks and that sort of thing, working for insurance companies doing actuarial work and risk analysis. You could potentially end up helping to design algorithms for computer games and things like that, and analyzing how these different algorithms need to be implemented. So there's lots of different things that you can do with these types of majors and these particular focuses in mathematics. You could also go on maybe and decide, hey, you want to do something else with applied mathematics, and you go into graduate school. You'll be well prepared to go into a graduate field, a graduate program, and focus on something more specific if you decide that that's something that's of interest to you. Now, one of the nice things about Medaille in particular is that because we're a relatively small school, and because every school needs to have a pretty big mathematics department, since everybody has to take mathematics, those of you who are going to be majoring in mathematics will find that there's a pretty low number of students relative to the number of faculty. So you will end up having a lot of personal contact with us and get to know us pretty well. And that's something that's really important. When I was an undergraduate, I went to a fairly small school myself, and it was really nice being able to personally know my professors in a way that is pretty unlikely to happen, honestly, at one of the larger institutions. If you go to a larger research university, you find that a lot of your classes, they're actually taught by adjuncts and things like that. And here you'll find that a lot of the courses in your major are going to be taught by the regular faculty because, well, there's not that many students compared to the faculty as you would see at a place that's a large research institution. Anyway, I hope that this has been informative for you, and good luck in your future decisions. I hope to see you at Medaille soon.